Well, thank you so much for that wonderful introduction. I'm very pleased and honored to be here, and I've got to say, you are a lucky bunch of people. Not because you're listening to me, no, because you've got this wonderful library of science, engineering, and technology here, and this fabulous. If you haven't seen this color exhibit, you need to go look at it. It's really amazing. A lot of people put a lot of time, effort, and money, I suspect, into it. And you also have this lecture series, so you're a lucky bunch. Now, what I want to do is to sort of contribute to, hopefully, your lives by talking about my research and my views about human aesthetic preferences for color. And the basic plan is going to be, first of all, I want to say a few words about what I call aesthetic science. This is, after all, a library of science, and when you tell people that you do aesthetics, they say, well, that's philosophy, that's not science. But I want to convince you that there is and can be a science of aesthetics, and that that's what I do. And I'm going to do it in the domain of color preferences, aesthetic preferences, and my particular view, theoretical view about where they come from, which we call the ecological valence theory. And then I'll tell you about a whole series of tests that we've done of the underlying assumptions of the ecological valence theory. And then if I have time at the end, and I'm not at all sure that I will, I'll mention this new idea that we have where aesthetic preference is really primarily determined by something I'll call good fit within a context. But I may not get there. So first of all, aesthetic science. What is aesthetics anyway? If you look it up in the dictionary, it's actually hard to find a good closed form definition. But here's one that seems pretty good. It's the study of the mind and emotions in relation to the sense of beauty. Well, that sounds good, and you think it tells you all you want to know, but then embedded in it is the sense of beauty. And if you don't know what that is, then you're no better off than when you started. For me, and the talk that I'm going to give today, aesthetics is the study of a dimension of human experience that I believe almost everybody has. I haven't run into anybody yet who says, what do you mean, what color do I like? And it's a dimension that goes from what we would verbally describe as, oh, wow, that's wonderful, to, oh, yuck, that's awful. Is an aesthetic science possible? A lot of people say, well, that's an oxymoron. You can't possibly have a science of aesthetics. After all, science is objective, and aesthetics is subjective, and science is lawful, and aesthetics is whimsical. And we've got these sayings, there's no accounting for taste, beauty's in the mind of the beholder. I mean, what a mess. So what some people would conclude is that a science of aesthetics is impossible, and I want to convince you that that's not the case. This picture keeps popping up. This is to remind me to tell you that I'm a photographer. And the reason that I got interested in this topic, I was a vision scientist first. I took up photography in the early 2000s, and I got interested in why it is I like the pictures that I like. And so I decided I know how to study this, and I got interested in different components of what makes me like a given picture. But anyway, that was a digression. There's three approaches to aesthetic science, that only one of which you probably sort of know about already, and that's the normative one. It's a prescriptive approach in which artists and critics try to analyze what people should like. And that's to be contrasted with an empirical approach, which is descriptive, in which a scientist tries to find out what people actually do like. The contrast here, I'm sure you've heard people say, well, I don't know whether it's any good, but I know what I like. Well, the first part, I don't know whether it's any good, that's the genuflection to the normative approach that somebody out there is an expert and they know what's good. You don't know what's good, but you know what you like. This talk is about what you like, and I don't know that there is anything about actually what the normative approach to color preferences might be. The third part is a theoretical approach in which we try to understand why people have the preferences that they do. So the normative approach, I'm not going to talk about at all, other than what I've just said. I'm going to concentrate on an empirical and a theoretical approach to the aesthetic preferences for colors. So Now we get to the first scientific part, where we measure people's preferences for colors. And how do we do this? Well, we present people with colors on a computer screen with a little line underneath. It's a slider scale. And we ask people to move the slider along the line to reflect their answer to questions like, how much do you like this color? If somebody likes it a lot, then they would move it over to the far right-hand side. If they can't stand it, they would move it over to the left-hand side. And if they kind of, have different degrees of liking, then they put it at corresponding points in the middle. We also study other aspects of color with the same subjects, like how red versus green is this color, how happy versus sad is this color, and I have lots of other talks that I could give about those topics as well. But this one is about how much you like colors. Now, although you've had other lectures before, I need to tell you briefly about the basic 3 dimensions of color experience that I'm going to talk about. They are called hue, which consists of sort of 2 component dimensions, redness, greenness, and blueness, yellowness. And that corresponds in this diagram, this color solid, as it's called, to the direction outward from the central axis. So it's a circular dimension. Saturation corresponds to where the color falls within the space outward from the central axis, where the central axis corresponds to white, black to white, and the grays in the middle, and they get more and more saturated or more and more vivid. And this dimension is called chroma by many color theorists. And the third dimension is lightness or brightness, and artists call this value, which has to do with how bright it is, and the dark colors are at the bottom and the light colors are at the top. So this space that I'm showing you, every color corresponds to a point within this 3-dimensional space, and the claim is that every color can be identified with a particular point within this space. If you want some more examples of that, you can go out to the exhibit and find out about CIE spaces and other spaces. So the colors that we've studied, we picked a particular set of 32 colors to study, and they consisted of 8 hues, the 4 so-called unique colors, red, green, blue, and yellow. So it's a red that's just red with no yellowness or blueness in it and so forth. And the combinations of those unique hues, which I'm going to call orange, purple, cyan is blue-green, and chartreuse is yellow-green. So this would be cyan, and this would be chartreuse. It looks a lot like green on this projector. I have no control over how these colors come out on this particular projector. So we study these 8 hues, but we do it at 4 different what we call cuts through this color space. I've just described to you what I'll call the saturated colors. They're the ones that are around the outside. They're the most vivid versions of each of those hues that we can produce. Then there's a light cut, which is essentially sort of halfway from the saturated cut to white at the top. There's a muted cut, which is halfway between the saturated cut and neutral gray in the center, and a dark cut, which is halfway between the saturated cut and black at the bottom. Okay? Those are our 32 colors, and I don't know whether anybody here is into CIE color spaces, but if you want to know what their coordinates are in a CIE lab color space, that's what they are. So what did we find? When we asked people to show them these 32 colors, we asked them to make these ratings. What did we find? So what I'm plotting here is their preference rating on that slider scale, the average across, this is 48 subjects, for red, orange, yellow, chartreuse, green, cyan, blue, and purple. Okay? So it's going from the long wavelengths here to the short wavelengths there. And basically what we find for the light colors is that at least Americans around the Bay Area prefer the cool colors to the warm colors. The cool colors being cyan, blue, and purple, and red, orange, and yellow are the warm colors. And for the muted colors, it's basically identical. Same thing. There's a little blip here at yellow. Why is it well, I'll talk about that a bit later. It may be related to the fact that it was done near Berkeley. The saturated colors look basically just the same, except at least most Americans like saturated colors more. They like vivid colors, at least when they're little squares on a computer. I'm not. The interesting thing is that when you look at the dark colors, something funny happens. That it's not just that they like the dark colors worse or they like the dark colors better. You get this, what we call an interaction, where there's certain colors that they like a lot less than the other colors. So compared to the lighted and muted colors, they really don't like dark yellow. This is a color that I call yucky poo for reasons that you may understand. They also don't like dark orange, which most people would call brown, okay? But they do like dark green and they do like dark red. So that's actually very interesting from a theoretical point of view, and as you'll see, it becomes key for our interpretation of these data. So if you wanted to say why people like the colors they really like and why they don't like the colors that they really like, you can make up a little just so story that goes like this. Well, they like saturated blue because it's the color of clear sky and clean water. They like saturated cyan because of the color of like swimming pools and certain gemstones. They like dark greens, it's healthy vegetation. They like dark reds, it's the color of ripe fruit. They don't like dark yellows and dark oranges because it's the color of biological waste products and rotting vegetation and yucky stuff. I mean, what can I say? So when I first started doing this research, I would say that and I would laugh. But at some point, as you'll see, I took these ideas seriously. And that turns out to be the ecological valence theory in a nutshell. So now what I'm going to do is tell you about a lot of differences in color preferences due to gender and culture and age and individuals and things like that, just to give you some background about what matters, okay? A lot of people think that there must be really big differences between men and women in terms of the colors that they like. These are just the averages over all those different cuts for the different hues, and basically you can see there's not a hill of beans worth of difference between at least American males and American females in the Bay Area. It's pretty much the same, but if you separate out these preferences by cuts, what you see is that males like saturated colors better than females do, and females like muted colors better than males do. Now, I thought that was pretty interesting because it was counterintuitive to me. I think you look at the colors that people wear, women wear bright, saturated colors, men tend to wear sort of muted colors, but then think about who they're dressing for. So I suspect that men wear the muted colors because women like them and that women wear the saturated colors because men like them. We can test this on gay populations, but we haven't done that yet. And just so you know that there's actually a very strong correlation between the male-female differences and the ratings that people give to colors about how active versus passive the colors are. The active colors are the colors that males tend to like, and the passive colors are the colors that females tend. I'm not endorsing anything here. This is not necessarily politically correct, but this is just a fact, a scientific fact, about males and females in the Bay Area in the United States. So why do I keep saying about in the United States? Well, we've studied these same 32 colors in a lot of different countries now. I'm going to first talk about the US versus Japan. These are the data that I just showed you before in the United States. And these are the same preferences for the very same colors from Japan. And what you see is that there are certain things that are similar. In both cultures, there's a tendency to like the cool colors more than the warm colors. But there are also differences. For example, the Japanese, and actually this is particularly Japanese women, like the light colors, especially the cool light colors, more than Americans do. And they like the dark colors less than Americans do. And in particular, they really, really don't like dark red, which Americans do like, okay? And we've studied these in a number of different countries, so I'm going to show you a slide that has all of these data actually, separated by the cut. So here's the saturated cut, the light, the muted, and the dark. And you can see there's a fair amount of noise and variation here. There's the light. The Japanese and the US people like the light colors better, but in Serbia and Mexico, not so much. And I should say in Serbia, there are huge gender differences. Serbian males do not like purple in any form. It's a girly color. But the interesting thing about this slide is that there seem to be some commonalities. In every culture we've looked at, the favorite color, averaged across people, is saturated blue, and their least favorite color is yucky poo. Now, I don't know that that's universal, but... So now I want to mention a couple things about differences in development, or possible differences in development, and species differences. So these are the data I've showed you before, but in a bar graph form. There's that warm-cool difference that I mentioned before. And now this is to remind you that hue is actually a circular dimension. It's not a linear dimension. And when you plot this in circular coordinates, what you find is that the warm-cool difference is really a big difference between blue and yellow. Okay? That's just an aside. So what about infants? What colors do infants like? Do they have the same preferences as adults do? The way you study this, by the way, since you can't ask infants what colors they like, you put two colors up in front of the infant, and then you just measure how long they spend looking at each of the colors. And the assumption is, and there's no way to check this really, that they look longer at the color they like better. When you do this with adults and you just tell them to look at the colors, they do spend more time looking at the colors they like better. We've shown that to be the case. But when you do that same experiment with 12-week-old infants, what you find is something actually very much like you find with the adults. And this is done with saturated colors. You find this sort of warm-cool difference. Later on, I'll show you that this isn't actually true when you look at the dark colors, for example. But if you look at another species, macaque monkeys, and you heard Jay Knight's talk, I guess, about macaque monkeys probably, they have identical color vision systems, biologically speaking, to ours. So if there were a really good biological explanation of color preferences, presumably this would look like the other ones, but it doesn't. It seems to be sort of monotonically increasing from red to blue, for reasons that I don't pretend to know. What about individual differences? The data I've been showing you so far are average data. This shows you just how bad it is. That black line there is the average data over all of these individuals, all right? And this is only about, what? I don't know, it's like 12 or 15 people, something like that. So they're huge individual differences, which I'm sure that you all know because you have different preferences from your husband and your children and so forth. And we'll come back to that. Okay, so now I'm going to talk about this ecological valence theory. Now I'm going to contrast two theories. One of them is a biological theory, especially since you had Jay give the talk about the biology of vision. And of course, anyone in their right mind would think that, well, the brain does vision and the brain is processing color, so it must be explained, color preferences must be explained by the brain. And in a sense, that's true, but I'm going to show you that not really. So the biological theory, there's a particular theory called the cone contrast theory, which says that people like colors to the degree that they activate certain cone-based contrasts against the background. And these are those short, medium, and long wavelength cones that Jay talked about. Did he call them that, or did he call them red, green, and blue? No, okay. So I thought he would say S, M, and L, as he should have, but... But in any case, so that's a theory. That might be the case. Here's the alternative. An alternative turns out to be largely the correct alternative. It's an ecological theory. And it says people like colors to the degree that they like the objects and things that are that color. I love this theory. It's a one-sentence theory. It's incredibly complex. And as I hope to show you, it's actually able to account for, at least make predictions about, all kinds of complex things like gender differences and cultural differences and individual differences and things like that. So it sounds like a very simple theory in the sense you can state it in one sentence, but it's got all kinds of complexity built into it because what are the objects? How much do different people like those objects? Does that differ across cultures? Why would it be different for babies than for adults? And so forth. So where did this idea come from? It was kind of one of those aha experiences that I had one day. I was thinking about color preferences, and I started thinking about other kinds of preferences. And in particular, I thought about food preferences. So what are food preferences about? Well, you can think about food preferences as being sort of a steering mechanism for an organism. That we don't actually have sensors for the number of calories in things, but we do have taste, which is sort of correlated with some of those things. So we like things that are sweet and sweet fatty things are things that have high caloric content, and for an organism to survive, you need calories. And things that are sour and bitter are things that are more likely to be toxic or potentially even fatal if you eat them. And so if you have a taste system where you like things that taste sweet and fatty and you don't like things that taste sour and bitter, then you're going to be oriented, you're going to go for the good stuff, the things that's going to be biologically good for you, and you're going to stay away from the bad stuff, right? It's very kind of simple and intuitive. Well, so maybe colors are exactly the same, except it's not so clear that it's just correlated with what you like, with things that are good for you and things that are not good for you. So what if an organism would have evolutionary success if they're attracted to good-looking stuff and they're repulsed by bad-looking stuff? To them, according to their color preferences. Now, it doesn't have to be the case that this is like built into your genetic code somewhere. In fact, it shouldn't be built into your genetic code. It's got to be, a lot of it's going to have to be learned. Because if you happen to live in a place where the good food is red and somebody else lives in a place where the good food is green, you want them both to be able to survive. You don't want everybody who's in the green good stuff to have to move to where the red good stuff is in order to survive. They need to learn that that's what's good for them. So, in fact, the more we study this, the more we believe that people's color preferences are indeed learned during their lifetimes, and I'll show you some of the ways in which we've demonstrated that. Okay, so that's the basic notion of the ecological valence theory. Now, how can we test this? Well, we can actually model color preferences for that biological theory because we know what the cone responses are to different kinds of colors, the colors that we studied. And what we're plotting here is the percent of variance accounted for, which is a measure of how good the theory, how well the theory does. The best it can do is it could account for 100% of the variance, okay? And the worst it could do, it could account for 0% of the variance. So, and this is the linear regression model that we used. And here's how well the cone contrast theory does. It can account for 34% of the variance, which is not very good. And this is just telling you what the various components, the short minus the sum of the long and the medium wavelength cone outputs are and so forth. But what about the ecological valence theory? How in the world are we going to measure its ability to predict what people's preferences are? It's not like we can go in and measure that like we can measure cone responses. So this is just to remind you, basically the theory says people like colors to the degree that they like all of the objects that are that color. It's like our brains are taking this global average of how much do I like the cyan stuff in the world, and that's how much I like the color of cyan. All right, so that's the idea. And this is the way that we did it. It's a little bit complicated, bear with me. There's 4 parts to the experiment, and the first one you've already heard about. The first thing is we bring in one group of subjects and we have them rate how much they like each of these 32 colors. Okay? Then we have another group of subjects who never rated how much they like these colors come in, and they list all the descriptions of all the objects they can think of that are that color. So for this particular cyan color, they might say swimming pool, tropical ocean, fish tank, blah, 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 turquoise, and so forth. Then we bring in another group of subjects, and we don't show them any colors at all. We just show them the descriptions that we got from these subjects here. How much do you like tropical oceans? How much do you like swimming pools? How much do you like fish tanks, etc.? And we do one more thing, which is we actually have another group of subjects. They see the descriptions and the colors. And they say, how good a match is there between this kind of object and this particular color? Because people, undergraduates in psychology will tell you anything. And you want to, they can say that this is the color of fire hydrants, right? So you want some way of, down-weighting those crazy things and up-weighting the good things, right? So So we do that, and I'll give you an example of how we then integrate these results into a single number for each color, okay? We call it the wave, the weighted affective valence estimate. Valence just means how much you like or don't like something, and here we're talking about the objects. Weighted means we use this match score as a weighting for that. So for this particular color, here's a list of at least some of the objects that people claimed were similar to this color, all right? They go from things that are like oceans or sea, and to things that are not so clear, like forest. I don't know where that came from. But we then get another group of subjects to say, how much do you like these things? And actually, the first thing you need to notice is that all these numbers are positive. There's not a single object on here that people are negative about, all right? The highest numbers, what, for clear blue sky, right, and clear water, right? Like I said, blue sky, clear water, right? And then you look at the match scores, and you see that they range from numbers that are pretty high for those guys down to pretty small numbers for forest. And then we just multiply those two numbers. That's the weight times the valence. And then we take the average. That's the weighted affective valence estimate for that color. All this work just to get one number for that color, right? And we get 32 of those numbers by doing this, for each one of those colors. And then we look at what the correlation is between the preference data for the 32, the average for those 32 colors, and the average weighted affective valence estimate. And in fact, it accounts for 80% of the variance. That's a huge number. I've never seen a number that big in almost anybody's research. And there's no estimated parameters. We got 34% of the variance with this biological theory, but there was fudge factor in there because there were weights in the estimation procedure, this multiple regression technique that we used, that allow it to sort of fit the data. There's no estimated parameters in these wave data. So this was brilliant. It just knocked my socks off. I went into this experiment expecting to show that it was wrong. I mean, it was like telling this story when I gave the talk, and I think, well, we can't just say that and not test it. Let's just show that it's not true so we can get on with the business at hand. Well, it turned out it was the business at hand. So now I'm going to go on and tell you about some tests that we've done of predictions made by this ecological valence theory. What about those cultural differences? Cultural differences have been talked about before in terms of like symbolic differences and so forth, but this actually has a very different take on it. To the extent that the objects in different cultures are different, and to the extent that people's liking responses to even the same objects are different. So in Japan, for example, for our light yellow color, one of the most frequently mentioned objects in Japan was tatami mats. We didn't see that at all in the US. Nobody mentioned tatami mats. And there are also objects that are very different. Seaweed, for example, in Japan is pretty well liked. I mean, they use it a lot in food, and to the extent that you like that food, then you'll like seaweed. But in the US, it's just that gunk that blows into the shore and smells when it gets hot. Basic prediction of this ecological valence theory is very simple. It's that if we measure the wave for American subjects separately from Japanese subjects, that there should be a high correlation between the American wave and American preferences. I've already told you that correlation is high. It's like 0.89. And that there should be also a high correlation between the Japanese wave and the Japanese preferences, but there should be a low correlation when you go across cultures, because there's different objects and because there's different valences about the same objects. And if you look in a table where you have you look at the correlation between the waves and the preferences, you should get high numbers along the main diagonal and lower numbers off diagonal. So what do we find out when we did these experiments? Well, these are the data I showed you before. These are the waves that we've measured, and these are the actual preferences of the US, and that correlation is 0.9. For those of you who don't know correlations, they can go from 0, which means no relation, +1 is the maximum it can be, and that's if they're identical. And -1 is the lowest it can be, and that's if they're identical flipped. In other words, if you get the sign wrong, and the colors that the people actually like are the ones where the waves give the low numbers. So there's a correlation of plus 0.89, very high. It's less high for the Japanese. I'll come back to why that might be later. But we find that the correlation within the US is higher than to the Japanese, and the correlation for the Japanese is higher than it is to the Americans. So that seems to hold up. We also did this in China. We have the same correlation for the US, of course. We haven't looked yet at the Japanese versus Chinese. But the Chinese color preferences are, again, not nearly as high a correlation as the Americans. But we find this unfortunate situation where the Chinese waves predicted the American color preferences better than it did the Chinese color preferences. Oops, what's that about? Well, here's what it's about, I think, part of what it's about. The reason we did this in China was because I had gone to China not too long ago, and I was impressed with how much symbolism there is in the Chinese culture around color. There's a particular red, which is the color of good fortune. There's a particular yellow, which is imperial yellow, the color of the emperors. I think green is associated with long life, longevity, and so forth. So I thought, let's look at the Chinese and see if we can find some evidence for these sort of symbolic effects. So we did, in addition to the object-based wave, which is what I've told you before, list all the objects that you can think of that are this color. We had people list all the abstract conceptual associations that they could think of for that color. So this same cyan color that was associated with objects like swimming pools and tropical oceans was now associated with peaceful, refreshing, lively, and so forth. And then we have people come in and say, well, how much do you like peaceful? How much do you like refreshing? How much do you like lively? How much do you like death? How much do you like shame, or whatever? And we had the same procedure. It's the wave procedure, but now it's a symbolic wave instead of an object-based wave. And what did we find? Well, for the Chinese, there are their color preferences, and we find we did the object wave, that's got a correlation of 0.59. We did the conceptual wave, and it has a higher correlation than the objects, and we do the two of them together, we get the best predictions of all. The correlation is now up around 0.80, which is reasonably within the same ballpark as the American preferences. So what I think is going on here is that America, as the great melting pot, that these sort of conceptual and symbolic associations from different cultures, which very often conflict with each other, have sort of gotten washed out, and what's left over is the object stuff. But in a culture like Chinese culture, where those symbolic and conceptual associations are still strong, they still have a particularly strong influence on people's color preferences. We have to test this, and I don't know how much it will. Oh, I seem to have. Oh, and this is showing that this is the same diagram as before, predicting the color preferences. This is just based on the object wave. If you look at the combined object and symbolic wave for the Chinese, it actually does predict their own color preferences better than it predicts American ones and so forth. So we do actually get a good correspondence that's consistent with the ecological valence theory. So what about individual differences? Oh my God. This is the big bugaboo. Almost nobody even tries to account for these things. But actually, the ecological valence theory has a very simple story to tell about it, and it's exactly analogous to the story about cultural differences. That individuals will have different color preferences to the degree that they have different preferences for the same objects, and they've experienced different objects. And this includes what I'll call idiosyncratic objects, although the data I'm not going to tell you about don't include those idiosyncratic objects. By idiosyncratic objects, I mean objects that you know and you know the color of and nobody else does. We told people before, don't list things that other people wouldn't know the color of. So if you said, Grandma's sofa, and you know that that's this bright orange color, and you may have good or you may have bad associations with it, nobody else is going to know what color that is. So if anybody used those things, we threw them out. We told them not to use them to begin with. But certainly people do have objects in their lives that nobody else has experienced, and they may have very strong emotional responses to them. So the prediction is basically, like I said, the same as before, that if you measure the waves separately for individuals, that my wave should predict my preferences better than yours, and your wave should predict your preferences better than mine, right? So what we did was a within subjects version of this wave experiment. I told you before we had different groups of subjects make all of these measurements. Now we do it all on the same person in this order. First we get color preferences, then we get object descriptions, then we get these matches, and then finally we have people rate how much they like the objects that they've described. So what do we find? Well, here's this correlation matrix, or at least a small part of it, because there's 48 subjects, there's not enough room here. So this is the correlation between the P wave as my personal wave, the personal wave for each person, for subject 1, correlated with the color preferences of subject 1, okay? Correlated with the color preferences of subject 2, subject 3, subject 4, and so forth. And as I showed you before, the theory predicts that the average correlations along this main diagonal, where it's the P wave for the same subject as the preferences, those should be higher than the ones that are not on the main diagonal. And this is showing you that the average correlation within subjects is about 0.55. And for the between subjects correlations, it's only about 0.40. And this difference is wildly significant for those of you who care about significance. So what it's telling us is that there's a certain portion of the wave that's sort of common to everybody, the correlation, and it's about 0.4. It's a really pretty reasonable number, but you get a bump in how well you can predict somebody's color preferences by getting their own personal preferences for those objects. And as I say, this doesn't include grandmother's couch. That's a much more complicated analysis, and I'm going to leave it out. Another thing that we did with this in this experiment, where we had these 48 subjects and we did all phases of the experiment with them, we wanted to look at whether if you got groups of people that had similar color preferences and measured their waves, would those correlations also be better for within group than across group? And so we did something that's called a k-means clustering, and I'm not going to bother telling you what it is, except that it's a procedure for putting into one group of subjects versus another group of subjects to maximize the correlation within the group and minimize the correlation between the group just in terms of their color preferences. So, and I'll show you in a minute what these two groups look like, because I think it's pretty interesting. And then we can test the prediction of the waves. So here's subgroup 1 and subgroup 2. And first we'll look at these correlations. They're the P waves for group 1 and group 2. And what we find is that the correlation between group 1's P wave and their preferences is higher. Oh, I'm sorry. And also for group 2, their within group correlation is higher than either of the between group correlation. So again, this fits with the ecological valence theory. Now let's look at what the difference between these two groups are, because I think this is kind of interesting. What I'm doing here is plotting the difference between subgroup 1's preferences and subgroup 2's preferences. And 0 means there's no difference. And you can see for a lot of the colors there's really not much difference. But group 1 likes blue a lot better than group 2 does. Group 2 likes purple a lot better than group 1. And group 1 dislikes the saturated colors more than group 2 does. Now, why these particular things should go together, why liking purple or disliking purple and disliking saturated colors should go together, well, maybe we have something to say about that in a minute. So this is one difference, is the blue versus purple, and the second one is the difference between the saturated and the rest of the colors. Now let's look at the corresponding P wave differences. And what you can see very clearly is that the objects actually predict the difference in the blues and the purples, but it doesn't predict this difference between the saturated colors and the others. And if you look at the difference between these two groups of subjects, it actually corresponds to other measurements that we made of natural versus synthetic colors. You can get people to rate how natural is this color, how synthetic is this color, and it turns out that there's a very high correlation between those two things. So I think this actually may be a kind of symbolic difference that's in the American population between the sort of subgroup 1, nature lovers, the sort of crunchy granola crowd, and subgroup 2, the kind of techno folks who really like the saturated colors and the gee whiz, and purples, which tends to be look more synthetic to us, I think. There's another prediction that the EVT makes, which is actually not about objects at all. It's about social institutions. And it says that if you like a social institution that's highly associated with particular colors, you're going to tend to like those colors. And if you dislike a social institution that is highly associated with certain colors, you're going to tend to dislike those colors. So for example, the Bloods and the Crips, these gangs, the Bloods love red and they hate blue, and the Crips love blue and they hate red. So we were going to bring the gangs in to the lab, but we decided that that would be self-destructive. Instead, we did the next best thing. We did a study of Berkeley versus Stanford undergraduates. Now, for those of you who don't know, Cal's colors are blue and gold, and Stanford's colors are red and white. And they came in and they did a study. We just asked them how much they liked the various colors. It included all of the colors that I've been telling you, plus Berkeley blue, Berkeley gold, Stanford red, and Stanford white is white. There's no difference between that. But these were particular shades of blue, gold, and red that we got from the website and from actually measuring the colors that were on T-shirts and sweatshirts and things like that. So what do we find? Well, here this is a preference score that's essentially how much you like that Berkeley blue plus how much you like Berkeley gold minus how much you like Stanford red plus how much you like Stanford white. So it's looking at the difference between the Berkeley colors and the Stanford colors. Preferences for Berkeley colors are going to come out to be positive, and lo and behold, that's what happens for Berkeley students. And preferences for red and white are going to be negative, and that's what the Stanford students have. Moreover, it turns out we also had people at the very end of the experiment rate how much school spirit they had for Berkeley, or how much school spirit they had for Stanford. And the correlation between how much more they liked the Berkeley than the Stanford colors, it's correlated about 0.4, which is highly significant, this is a scatter plot, with how much school spirit they have. So the more you like Berkeley, the more you like blue and gold, and the less you like red and white, and vice versa for the Stanford students. And the effects are even stronger when you look at the color pairs. So we had blue squares in gold squares and blue squares and so forth. And here the correlation goes up to 0.51. So this is actually evidence, I think pretty convincing evidence, that these color preferences are learned, unless you believe that people go to a school based on what colors they like. And not just which colors they like, but they also have to go to a school where the rivals are colors they don't like. Right? What are the chances of that? Another experiment that we've done, and I'm noticing that I'm getting close to the end of my time here, is that we've actually shown that we can change people's color preferences, not by huge amounts, but by doing an experiment like this. They come in initially, they do preference ratings for all of our colors, and then later they're going to do the reference color ratings of the same colors, but in between we show them a slideshow, which they think is part of a different experiment. And in this slideshow, one group gets good red stuff like raspberries and cherries, and they get bad green stuff like pond scum and mold, whereas the other group, of course, gets bad red stuff like bloody eyeballs and good green stuff like kiwi fruit. And then we measure their color preferences again, and what we find is consistent with what we expect, that the good red stuff increases their preference for red, and the bad green stuff reduces it, but for the good green stuff increases their preference for green, and the bad red stuff reduces it for red. Those are not huge differences, and they don't last all that long, but they're there. What about infants? We did an experiment, since nobody had ever done any of these experiments with any colors except the saturated colors. We decided to do it with light colors and dark colors, because that's where we find these interesting interactions going on. And these are showing the looking preferences for adults versus infants for dark red, dark yellow, dark green, and dark blue. So dark yellow, this is yucky poo, right? And for that, the adults really don't like it, and they don't spend very much time looking at it, but it's the baby's favorite color. And the correlation between the baby's looking preferences and the adult looking preferences is actually minus 0.5 or more. So they're very different, and I think it's because the ecologies, if you will, of the baby are very different from the ecologies of an adult, and but a lot more work needs to be done with that. I mean, the ecological valence theory predicts, for example, if the baby's bottle fed and we change the color of the nipples. A lot of nipples, by the way, are kind of dark yellow. If we change the colors of the bottles and the nipples, that their preference for the color, that color is going to go up. Or if you give them a toy that's that color and they really like to play with a toy, it will go up. We haven't done those experiments yet. Okay. Now, I think I'm going to have to skip this last part. Basically, can I go over a couple minutes? All right, I will. So what we did was we had brought subjects in. I'm going to show you that context can absolutely reverse people's color preferences. We had people come in and said, we want you to pretend that you're a graphic artist who's advising bands on the principal color for their next album. And we had two fictitious harmonious bands. One was called Peace and one was called Unity. And we played music by Celine Dion and Enya. There was no vocals in it. It was just the instrumental parts of these things. And you know what that sounds like. It's easy listening, kind of floating in the warm bathtub kind of music. And then the other two bands were called Chaos and Friction. And they were basically headbanger rock bands. I did once upon a time have a thing to play here, but good for you, I don't have them. These are the colors that we looked at: saturated orange, saturated chartreuse, saturated cyan, and saturated purple. And basically, we had people first say, what colors would be best? What colors would you like best for this album? And then later we said, what colors would fit best with this music? So here are the preference judgments. And for the harmonious bands, they clearly like purple and cyan much better than the cool colors, much better than the warm colors. But for the dissonant band, it's exactly the opposite. They like the warm colors better than the cool colors. And when you have them make these judgments of the goodness of fit between the colors, the colors and the music, you find exactly the same thing. These data are almost Xerox copies of each other. And it's not because these people did these judgments first, because you can get other people to make these ratings who haven't been in that part of the experiment, and you get the same thing. In fact, I have another entire hour-long talk that is just about what colors go with what music. But that's for another time. This is just to say that you shouldn't think about color preferences as being, in some sense, fixed or permanent. They change during your life, but they change also in terms of contexts. It's not that this is going to make you like orange if you hate orange, but you think that orange is the best color for this context. We've also done experiments with these very same colors, looking at how much would you like this color as a color of a t-shirt or a couch or the walls of your living room and so forth. And it makes a big difference, particularly in how light versus dark the colors are. So the wall colors you want to be light, the couch colors you want to be dark. So context matters a whole lot. So what I'm going to sort of summarize here is that we're now thinking that we need a new EVT 2.0, if you will, which is still ecological because it's about the relationship between an observer and their environment, but it's been expanded to include these conceptual and symbolic kinds of associations as well as the objects. So it includes all kinds of color associations. It would be able to account for different cultures that have different weights on their conceptual versus object associations, like I showed you. In the USA, objects alone account for almost all the variance there is, and in China, it's actually weighted in the other direction. And we're now repeating these conceptual experiments in the US. The problem with doing studies in China is if you don't speak Chinese, you don't know what's going on. You look at the list of things that they've associated with it, you don't know what it is. Anyway, so my summary and conclusions. First of all, I hope to have convinced you that aesthetic preferences can be studied scientifically. There is a scientific study of aesthetics, and that there are systematic color preferences that exist across individuals. There are many factors that influence our color preferences, including culture, objects, gender, institutional affiliations, and so forth. They're largely caused by people's affective responses to objects that are that color, but also to the symbolic and conceptual things that are associated with the color. And that color preferences may be understandable as goodness of fit to an appropriate context. Finally, ecological approaches, which we're trying to explain, and I think succeeding in explaining people's color preferences. It's happening in their brains. This is to go back to the first thing, the sort of biological versus ecological. It's not that it's not happening in their brains. That's sort of the how question. It's the head bone connected to the neck bone kind of thing. This neuron makes that neuron fire and blah, blah, blah. But the why question, so why do you like those colors? That answer is ecological. It's about the relationship between an organism and its environment, and presumably what's good for the organism within its ecological niche. I want to thank my many collaborators, my sponsors, NSF and Google. I want to thank our main sponsor, by the way, which is Amy's Natural and Organic Foods. When we started this project, let me tell you, no funding agency in their right mind would touch it. So what we did was, my collaborator in this was Karen Schloss, and her uncle works for Amy's Natural and Organic Foods, and he gave us several $1,000s worth of pizza coupons with which we paid our subjects. And finally, I want to thank you for your attention. You've been a wonderful audience.
All right, we have time for a few questions. Raise your hand. I'll come by with a microphone.
Hi. Women sometimes pick clothing hues based upon those that complement their skin tone. Did you guys look into anything like that at all?
We have data. Okay, so the first thing to say is that we have mountains of data that we have not yet looked at. One of the things we have is eye color, hair color, skin color, and things like that. This is people's self-ratings of what they are. We haven't looked at it, so I don't know. We have looked some at seasonal differences, and there are some seasonal differences. People tend to like dark, warm colors, like the colors of falling leaves in the fall better than they do in the winter, and in the spring they like the lighter, warmer colors much better. So there are seasonal effects which also influences fashion and things like that. And I should say, I didn't say this and I should have, that the ecological valence theory is primarily talking about the influences of object preferences on color preferences. That doesn't mean that there aren't influences in the opposite direction. I mean, we certainly have color preferences influencing our object preferences. I bought this shirt because I like this color blue, right? There were lots of other colors out there. There was no difference between them except color. And to the degree that people say, wow, I love that shirt, it's the same color as your glasses, it really makes your eyes look blue, and I get off on that, then I'm going to like this shirt more, and therefore I'm going to like the color blue. So there are these feedback loops that take place between objects, preferences, and color preferences, and nothing that I said should be taken to imply that there aren't those influences of color preferences on object preferences.
What is, you probably haven't studied this, but you may, the impact of other colors on a color preference. That is to say, in music, sounds, if you combine it with a different sound, there's a total change in appreciation of what you think of a particular sound. And it seems to me that color, if you say, well, what do you think of this color, but it's in a background of a different
Yeah, we have studied that. That's another whole hour-long talk. Yeah, we've studied preferences for color combinations by having a small square inside of a larger square. And see how to answer the question. I think what we've shown is that people like Chevreul, if you don't know who Chevreul is, go look at the exhibit, who is an art theorist of the prescriptive type, telling sort of what you should like, got it wrong in a number of ways. Because you have to distinguish between how much do I like this pair of colors as a pair, as a whole, from how harmonious these colors are. Everybody, or pretty much everybody, assumes that color preference for combinations is the same as color harmony. They actually use the same words interchangeably. It's not true. It's just like in music. Everybody would agree that Mozart is more harmonious than Stravinsky, but some people like Stravinsky, some people like Mozart. You can have harmonious people who like disharmonious color combinations. And the third thing is that they don't distinguish between how much you like the color against the background, just how much you like the foreground color against the background, because there are well-known interactions called simultaneous color contrast, where, for example, a yellow square on a blue background looks like a much more saturated or vivid yellow than it does against an orange background. Anybody in here who's a graphic artist, a painter, a photographer, worked with color knows this intuitively. And in the US at least, we like saturated colors more, so we're going to tend to like the contrastive combinations more, just because we like the foreground color more, because it's more, in the background color, the blue is going to look more saturated with a yellow square in the middle than it is with a green square in the middle. So it goes both ways. So it is influenced, and it's influenced in systematic ways, and there's a paper there's a paper in a scientific journal out there where you can read more than you want to know about that. The music stuff is even more complicated, but like I said, that's another whole topic.
Sorry to interrupt. Question back here in the middle of the room.
Do you think there's any scientific basis called upon by these groups of people who tell us what color automobiles and appliances and wall paint we're going to buy 3 years from now?
Any scientific basis? Well, there could be. I don't know whether there will be. I know how this works. They make these predictions. Actually, Karen Schloss, who was my collaborator, worked for one of these things before she decided to become a scientist. And it's basically, as far as I can tell, it's self-fulfilling prophecies. So these companies are trying to predict what it is that's going to be the big color next fall or whatever. And so they have these group thinks and they come up with a set of colors, and then what do? They sell their color set to the designers and the clothes makers and the furniture makers and things like that. So next fall, those are the colors you have to choose from. So, so there could be a scientific basis. You could predict some of these things, and we have studied, as I mentioned, the differences between people's color preferences for different kinds of objects. And it's not just like, this is very intuitive. You'll get this immediately. It's not even by category like car, because if you ask people how much they would like each of those 32 colors for the color of a Volkswagen Bug and a Lexus sedan, very different. Nobody wants a bright yellow Lexus sedan, right? The colors are predominantly black, white, grays, maybe some dark blues for the Lexus sedan. For the bugs, yellow, actually saturated yellow is one of the favorite colors, and saturated green and saturated blue and stuff like that. So it does matter, the contexts are different, and we have studied why they're different. It has to do with different images and things like, well, the dark versus light differences have to do with cleanliness. You don't want a couch that shows dirt. You want walls that are going to brighten the room and stuff like that. There's a paper about that, too. We've written lots of papers.
Yes, is there any consideration for a longitudinal study on your participants in the Stanford Berkeley to see whether the color preference lasts?
Yeah, it's a great idea. I would like to do it, but follow the very same people and see if their color preferences. What I would really love to do for a longitudinal study to show the sort of ecological effect of these things, I'd like to find out a football team that's going to change their colors before they actually change them. And then I could study their color preferences before versus after. But I've looked into this, and the fact of the matter is that when a team is going to change its colors, that is a secret that is guarded more closely than any military secret you can think of. So, and I've not yet been able to find anybody who would deign to let me know that that's going to happen. But I'm sure that that would be a monstrous effect.
We'll end with one more question. We have a question from an online viewer, Jack. He wants to know, do you know the work of Shigenobu Kobayashi? And if so, what is the difference between his semantic differential color preference studies and your EVT?
I don't know that name, so I can't say what the differences are.
All right. Well, that will conclude our Q&A tonight. And thank you for attending tonight's lecture in person and our live stream audience. The color exhibition will be on view through March 14th, 2014, so you have plenty of time to come look at it. Thank you and good night.
Yes, thank you for coming.